Looks like
9. Well, welcome to the June 14th, 2022 session of TangerineSDR and
June 13th.
What was that?
13th, not 14th.
UTC, it's 14th.
Ah.
So, and it is the session of TangerineSDR and Hamside technical session. My name is Dave, KV0S, and this week I've been recording or editing and posting many of the forum talks from Dayton up on Tapper Digital. So if you want to, so we did the Tapper forum, the SDR forum, the banquet, AMSAT Tapper banquet, and the Hamside forum. But the Hamside forum, I only have two of the 4 videos because I only had the slides from 2 of the presenters, but not the 2 students. So I'm waiting on the students to finish those out. So that's it for me. Next on the list, we have Dave, KD0EAG. Go ahead, Dave.
hello. Not a lot of excitement to report from here. Seems to have been an unusually unproductive week, even by my standards lately. Not really much to tell. Over to you.
Fine business. Next on the list, we have Bill Engelkey, AB4EJ. Go ahead, Bill.
Well, good evening. Spent the last week at the CCMC conference in Washington, D.C. It was a conference that talked a lot about how you mathematically model the environment around the Earth and between the Earth and the Sun for predicting what is going to happen to astronauts in orbit. And an awful lot of it was like listening to the Chrysler turbo encabulator thing. It was just long strings of jargon and incomprehensible stuff that I had no familiarity with it. And most of the speakers spoke English as a second or maybe even third language. And so it wasn't very productive for me. I mean, I gave a presentation on the machine learning using amateur radio data, and it was well received. So now they're putting the lobbying on me to go to the next meeting, which is unfortunately going to be in Portugal. So we'll have to, I don't know if we have budget for that, but anyway. The weekend was kind of fun though. Participated in the VHF, the ARRL VHF contest, and 6 meters was open. And interestingly enough, 2 meters was open with my new 17 element beam and amplifier I bought at Dayton Hamfest. I was able to work stations 500 to 1,000 miles away on 2 meters. So that was kind of fun. So, but I didn't really know what to expect, but my signal was heard as far away as Connecticut and Minnesota. Anyway, so but not very much to report. I mean, other than I've been working on the grape and I'm trying to upgrade it to Ubuntu 22 dot something. I can't get the serial port to work, so I can't get I can't read the GPS data, which you need for various reasons. But anyway, hopefully we'll get that figured out. Back to net.
Well, fine business, Bill. And next on the list is Bill in 8ET. Go ahead, Bill.
Catch me before I wake up. Just got on. Haven't got anything to report this week. I've been working in the yard, cutting brush and piling that up and getting it hauled away. And ready to collapse tonight. So back to you.
Fine business. And next on the list is David Mcgawe in one HAC. Go ahead, David.
Hello, everyone on the net. Been working on second Baffin Island receiver, which needs to get out this next week or so. Trying to debug a balky repeater that seems to have lost some sensitivity. We're getting ready for our big public service event, which is called the Proudy. It's a 100-mile bike ride to raise cancer money for our local cancer center. That happens just after the 4th of July, weekend after. So that's our big event coming up. But I guess that's about it over here. It's cool weather. Thanks to everyone else for having the hot weather, so we balance it out on the cool side. Back to net.
Well, fine business. And it may be coming your way, I think.
Oh, it eventually does.
Yeah. Next on the list is Hyomin Kim. Go ahead, Hyomin.
Hello, everyone. Yeah, it's been a while. I've been pretty busy with a lot of other stuff, especially like summer. I'm running the summer internship program for undergrad students that eats up my time a lot. And then, I was told by Nathaniel that we should take some action for the publication of our magnetometer projects. So just as I don't know who's involved in that, but for Grape or Tangerine radio instrument, some of you guys are working on publications. So we have to do the same thing for magnetometer. So I guess at some point we have to Dave Witten, Jules, whom else? Scotty, and anyone who contributed to magnetometer project should sit down together to figure out, how to approach the publication. So that's one thing. The other thing is, this is a question probably for Dave Witten or someone else. Basically, with my student, I'm focusing on the scientific verification of the magnetometer system. Currently, we have finally one dedicated student who is actually looking at data for scientific usefulness of the magnetometer system. One thing that we realize is that some formats, the data formats are a little different, maybe because that was taken before the system was completely finalized or something. So I don't know if this is something that we should address, or at some point after the system was upgraded, maybe this is not something that we should worry about. But anyways, that's one trivial stuff. The other issue that we need to figure out, which I think the most important thing is to make sure that the quality of the data is within our standard. For example, if the sensor is not properly oriented, for example, this could be installed by many other amateur radio folks who may not know too much about magnetometer installation. So that's something that we have to really think about once we distribute the first batch of mass production items. So that's something that I will be working on, but I'll keep you guys in the loop so that we are all aware of this data format and data quality assurance. So back to that, that's all. Yep.
Dave.
That brings up something I forgot to mention. I ended up with two shielded Ethernet cables that were supposed to be used in our repeater system, but weren't needed. And the guy who bought them thought I had told him that I would use them in experiments. And I'm saying, I didn't say that. but I've got 2 cables that could be used for magnetometers if we wanted to deploy them somewhere.
Oh, very good.
Hillman, I'd be happy to discuss those things with you a little later in the general discussion.
Sure. Yep. Good. Thanks.
Okay, well, let's continue on the list. Next is Jim, K4BSE. Go ahead, Jim.
Good evening all. Sorry I'm late. That's the way the evening has been running. Unfortunately, I don't have a whole lot to report now. I've kind of got those new antennas in position, but not quite. I got to reposition them some, but boy, it's hot here. And I'm just not going outside if I don't have to now during the day. That's about it from here.
Okay, fine business. And next on the list is Dan Babcock. Go ahead, Dan. In for XWE.
Thanks, Dave. I am having misery with my computer here. Now it says it can't detect the camera. So can you hear me?
Yes, we can hear you fine.
Okay, so at least the microphone's working. Maybe that's the worst of both worlds. Okay, so anyway, not much to report. Been kind of busy doing a bunch of stuff. And that's about it from here, Dave. Back to you.
Okay. Well, just as Nathaniel's about to walk away, I want to call on him. Nathaniel, W2NAF, go ahead if you have any comments.
Yeah, hi everyone. I'm live from the Youth on the Air event in Cincinnati, Ohio. I'm here in the ham shack of WC8 VOA with a bunch of young people. This is at the VOA Museum in Cincinnati. So this is actually where the original control room was of the Voice of America. So I gave a keynote speech here last night. Veronica, hey Veronica, wave to the Tangerine group. Everyone say hi.
Hello.
Yeah. So yeah. So if you want to talk to them, they're on 14. Whoops. 14.245 megahertz on 20 meters.
Okay.
And they're on 7.232 on 40 meters.
So while you're there, remind Veronica, and if Diego's there, I still need some slides from them.
Okay, I'll let Veronica know. Yeah, it's a little quieter, but there you can see them.
Hello.
Yeah, they're very excited.
Well, have fun. I'm going to continue down the list.
Thank you.
Okay, next on the list is Jay, WB8 SBI. Go ahead, Jay.
Howdy, everybody. My big event will be coming up this Wednesday and Thursday, the Embedded Security and Automotive Conference here in Michigan, about an hour from my house, which will bring together about 200 or 300 of the leading cybersecurity people in the automotive industry for 2 days of really intense automotive cyber-related activities from both industry, government, academia. It's really intense. So that's what I'll be doing. Now, earlier, Bill, I think it was you mentioned turbo encabulator. Did I hear you say that? Well, as it would be, I was at Chrysler when shortly after that video was made, and it was an actor doing a spoof on the Chrysler A604 Ultra Drive electronic transmission. So, it was a spoof on how to diagnose it, because it was the first Chrysler's first electronic transmission and one of the industry's first electronic transmissions. And of course, everyone in the dealer world had to go on a learning curve to how do you diagnose and repair this thing. So it was hilarious when they showed it. It was one of those videos that was passed around the various engineering teams, and we were all just hilariously. It was really done well, and it was done by the same actor that made the official diagnostic video that was circulated to the dealerships. That one was never circulated to the dealerships. It was strictly an internal one. So yeah.
He finishes up with saying, it's not cheap, but I'm sure the government will buy it. And he holds up this banner, $750 million.
Well, there's some other stuff about turbo encabulator. It was just like sight gags galore and of the script, but you have to be familiar with that particular system. So I'm one of the few guys left around that worked on it that is familiar with it. But anyway, that's what turbo encabulator was. It originated from Chrysler in the early 1990s, circa 92, 93, 1990, 91, somewhere around that time frame. Anyway, amateur radio wise, we had a good Parks on the Air up here with the county ARPSC. And other than that, I'm just about recovered as one of the 31,300 of my fellow friends and brothers in amateur radio from the Hamvention. Other than that, take care, everybody. Stay cool in the upcoming heat wave, which is going to roast the central U.S. Starting tonight and going through the end of the week. Take care. 7-3, everybody.
Okay. Thank you. Next on the list, we have James, KG4 DSG. Go ahead, James.
Evening, Dave, and the group. Not much to say here. We're just trying to stay cool and out of the weather. I did post a link in the chat about the Turing Pi Kickstarter. I don't know if anybody knows about it, but they have wildly exceeded their goal. They were shooting for $64,000. They are now over 2 million. It's a Pi 4 compute module cluster motherboard. You can plug 4 compute modules in and they operate as a standalone cluster. Just day and a half left before they finalize. I'm just trying to decide whether to spend the money on it or not. I figure I got at least 24 hours to go. With that, back to the group.
Oh, fine business. That's an interesting piece of work. So thank you for reminding us. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I had quite a busy week. I worked on my EBNOT rig. EBNOT is a coherent Bpsk mode for frequencies below 9 kilohertz. What I've been doing is building a rig with a GPS module, a Raspberry Pi, and an audio injector stereo sound card, very similar to the VLF system that I built, that's installed at Nathaniel's house, that's capturing the VLF spectrum. This will generate a GPS time or a phase and frequency locked carrier with a Bpsk modulation. So there are 2 main transmission modes in the Dreamers band, which is below 9 kilohertz. Both one is phase frequency and phase lock carrier, and the other one is the coherent Bpsk mode that's also frequency and phase locked, called EBNOT. And you can use, so there are 2 programs that are open source that you can file on your Raspberry Pi. EBNOT is what generates the modulation. Then there's a program called EBSynth, which will use either a 10 megahertz divided reference or pulse per second signal from a GPS and generate either a phase phase and frequency lock carrier, or EBNOT modulation. So I'm building this little, everything is going to be put in a Hammond enclosure. I ordered the sound card, and I have the Raspberry Pi. I was able to get it cheap when they were actually $35. So I'm still working on the mechanical fitment inside the enclosure. I'm gonna mark everything and drill some holes and get some hardware and mount everything up nice. Also, I was able to do some more analysis on that spheric that I captured from that ELV event that occurred in Kansas. I used the spheric's time of group arrival, and what I did was using VT Toga, which is a utility in VLFRX tools, I was able to extract a bunch of data from the spheric's time of group arrival, using and I was able to plot it with a script from the author of VLFRX tools. So I sent an email to the a group with the plot, and there's some really interesting information. The arrows indicate, for the first plot, the arrows indicate peaks. For the second plot, the actually, I could probably share it quick, but so with this, oops. So with this information, you could actually see different sorts of analysis of this spheric, which is really, really cool. There it is. So as you can see, so the first plot is a time domain plot of the time of group arrival. So we're talking about the frequency content of the spheric, and these arrows indicate the peaks. The next plot is the analytic magnitude. And this is useful if you want to do analysis without respect to the phase of the signal. The third plot is the instantaneous frequency. And you could see a very interesting peak here towards the end of the buffer. The fourth plot is the spectrum of the spheric, and that's really interesting to me because depending on the ionosphere and the propagation modes, the frequency content varies quite a bit. And the last plot is the unwrapped phase. So all this information was generated by a program called VT Toga that allows you to extract a time of group arrival and this information from a recording of a spheric. And this spheric was captured on May 31st at the receiver at Nathaniel's house. So that was actually pretty cool. This was actually captured locally. I'm going to stop the share. That's all I have. Back to the net.
Well, fine business, Jonathan. Next on the list, we have Tom in 5EG. Go ahead, Tom.
Oh, good evening, Dave and everyone. Not too much to report. I packaged up the FPGA code and the C code that's partial right now that implements the data engine local host protocol. And that tarball was about 5,200 files. And I sent that to Kong, and he's had a few questions about versions of the tools for Quartus. And hopefully, once he's had a chance to get a working laptop on Linux, we can have a couple of phone calls. There's enough in there. I think we need to have a couple of phone calls to work out how he can do the build and how he can get started with it and see if he can duplicate the working gigabit Ethernet and engine to handle the UDP packets. So that's about it for the week.
Well, fine business. And unless I missed somebody, I think that's everyone on the list, 13 participants. Oh, Scotty just arrived. Scotty, you want to make some comments?
Oh, hold on. Oh, there we go. Sorry, I'm late. I'm just sitting here at the computer working, and I look down and it's like, oops, there's the time. It's past. Well, anyway, got the adapter boards back. I haven't had a chance to test them yet. And next week, no, the week after the 26th, we get the 500 magnetometers. So we'll be frantically trying to get those out the door too at the same time. And it's going to be an after field day thing. But no comments from the CM on them. So I guess that means everything is good. So look forward to that, and trying to get the adapter boards out so I can get one over to Kung at least so he can put our logos up on the display. Oh, and we got the, forgot the most important part. Last week I got the FPGAs.
Yay.
Woohoo! So they're in my hand. I haven't opened the package yet to verify the true intel, but it says Intel all over it. I'm not going to do that. So it'll be building probably next week or the week after. Notice in the progress of going through the BOM and making sure we have everything and cataloging everything, because it's a pretty big, massive BOM, and we don't want to have any shortages. So she's been through it once before, but it's been a while ago. So she's going to go through it again now that we have the last part. Sounds like a soap opera, right? The last part. So that's it for here.
Very good. Well, that brings us to the end of the list. So we're open for general discussion.
I was going to mention, I just had a very interesting conversation this afternoon with TJ Rogers of Cypress. Turns out he's a Dartmouth grad. He's back for reunions. And I hadn't realized he was not only founder of Cypress, but apparently they used to fab the Altera FPGAs.
Really?
Altera, I knew Altera didn't have their own fab.
I thought it was TSMC that did the fab.
What's that?
I thought it was TSMC that did the fab.
That would have been later, I presume. Okay. This would have been at the very beginning.
So did he have any good comments about supply chain and whether we're going to see any end to it ever?
No, he's just got his fingers into a whole bunch of other things. He's retired from Cypress long ago.
Yeah, so he's retired now. Good. So
yeah, his big thing right now is micro converters on solar panels.
Oh, okay. I mean RFI generators?
Yeah. Well, I was giving him a hard time about that. He said, "Oh no, they don't generate any RFI."
Baloney.
Yeah, right.
I know guys that can't operate during the day because the solar panels in the neighbors' houses just jam out their radios.
Yeah, this is New Power, one of the companies that does that.
Yeah,
that's his company. He did the venture capital for it.
Oh, okay. That's NUPOWER, right?
Yeah. Yeah, he bankrolled that apparently.
So I hear and I'm seeing back east, there's huge heat wave coming through.
Yeah.
It's right here in Columbia, Missouri.
Yeah, I saw it. So you're the epicenter.
We're 97 today and 98 tomorrow, regular temperatures, and quite humid.
Yeah, we're 106 today, but that's normal. I mean,
we're at a sweltering 67.
Oh, your turn's coming, Dave.
Oh, I'm sure it is.
I bet
I like being in this little backwater up here.
I bet when it gets to be 100 in New Hampshire, it's really miserable.
Oh yeah, you know, it didn't used to do that. I never saw 100 until the last few years. It would go to 99, but never 100. But we poke over there now.
I lived in northern Illinois, and you know, I remember it being hot, but of course, being a kid, I don't really remember what temperature it was, what the numbers were. You know, it was just hot out. When you rode your bike, you got real sweaty, but I don't remember 100-degree days either. I don't remember people going on and on and on about how it was a heat wave and it was going to kill everybody and yada, yada, yada. So don't know what that's about. Global warming, right?
It is. Been watching it for 40 years.
Yeah. But we're supposed to have, what I've noticed here is that the people are getting a lot more sensitive to the same temperatures that it's always been. So now when the Weather Service says it's going to be 113, now it's a warning, heat advisory. And it's like, you know, if you live here and you can't know enough to stay in out of 113, you know, you don't deserve to live here. Because it's just, I mean, it's like when it's raining and you don't come in out of the wet, you know. It's
frankly, I'll take your 113 over our 100, yeah. Because our 100 is humid.
Yes.
Now, there was one year I was out in Boise, and it hit 112 that I saw. And plus you were in the shade, it really wasn't that bad, and you had to drink a lot of water. Come back to Boston, and I'm sitting waiting for the bus to get home, and it's basically 199 degrees and humid. And say, I take the 112 anytime.
Yeah. Well, our dew point is 40 degrees.
Yeah.
So it's like the relative humidity is like what? That's 4% or something? Oh, yeah. 11%. And actually,
I remember specifically being in Utah with, I think it was 93 degrees with an 18-degree dew point.
Yeah, yeah. We oftentimes have below freezing dew points.
Right.
And it's like, hey. And I was out on my bike one day. I have a radio on my bike, and I was on the local repeater, and the guy says, it was 112 today. And I mean, even when I was riding, it was like 108 or something, because it was just past sundown. And he's saying, what are you, crazy, going out exercising, riding your bike around when it's so hot? And I said, look, it's 4% humidity. I got a 15-mile-an-hour breeze. It's comfortable. It really is. It really is. I mean, compared to, you know, when the humidity goes up, it's nice. I wouldn't say it's like, you know, you're 68 degrees or whatever, but it's certainly not life-threatening baking hot just because it says 108.
We're actually going to be dipping down into the 40s next week.
That's for the lows, though, right?
That's the low, but the highs are 60s and 70s. We're not really getting the hot weather yet. Yeah, we will.
Well, our low.
You'll get your revenge.
Next Thursday, it's supposed to be 113 with the excessive heat watch, and the low will be 86. So now that's I don't like that, because when the low's only 86, that means the humidity's going up.
Yeah.
Because the low humidity gives you a greater temperature difference between day and night. And so you can get down, and even if you're 113 in the day, you can get down to the 70s at night, which is not bad.
By the way, Nathaniel, are they still on the air?
Yes, they are.
What's the call?
Yeah, because I'm on 7.232. I was hearing them when you mentioned it. I'm not hearing it now. Maybe propagation change.
This one's on
QSL 70.
This one's on 14288.
QSL 73.
Yep. They're on 14288. Hey, what frequency are you on?
14288.
And they're on 7255.
There's someone else.
Oh, 7255.
The Tangerine people are trying to look for you guys.
I'm visiting Ohio currently.
They're going to go to a clear frequency, and I can let you know.
All right.
So what is there a contest going on?
So far?
This is the Youth on the Air YOTA program that Neil Rapp is running. So we have about 20 people ages 15 through 25 as campers here at the Voice of America Museum. And
cool.
It's really awesome. So you know, the first day they came in and they got to tour the museum, and then they have amateur radio activities planned all week. There were talks on contests. They get to operate the station here till like 11 o'clock every night. This morning we built these like mixer attenuator kits and antennas for fox hunting. So we're doing, they're teaching them how to do fox hunting, and everyone goes home with a fox hunting antenna kit. We did eyeball QSOs, QSO sprints. They're going out to, they're going out to the Kings Island amusement park tomorrow. They're supposed to do an EME demo, just all sorts of great stuff.
And where is this?
It's at the VOA Museum, the original Bethany translator station in Cincinnati, Ohio.
Oh, cool. Okay.
So right now I'm sitting in the original control room of the VOA broadcast facility from World War II.
Oh, that is way cool. And are your students down there too?
Yep, Veronica's here. So
I thought I heard her voice in the background.
Yeah, so sure. So I can try and stand back here. This is the whole station. And so ICOM is lending a bunch of radios. So Veronica and Adam are on this station. They've got a IC 7610 over there, and there's a 7300. ICOM 7300 over there. Another 7610 over here. And then we have, this is the club's normal station on that side of the room.
Wow.
And then if I go out here, a lot of the lights are kind of turned off, but I can show you. This is where the actual museum is. So the glass room over there is it's the console, the control console that was installed during the Cold War. So the original control console from World War II was over there. And then in the 1960s, they created that air conditioned there to be the console. And it can go in here. And they have, there's one of, I'm sorry, I think they're doing a podcast in there right now. So I'm QRMing them. But yeah, a lot of really neat exhibits. They have some things along the side here about the USS Courier, which was a translator ship that was stationed off the side of Greece, off the coast of Greece during the Cold War, that transmitted VOA broadcasts into the USSR. And that's all along here. So it's a really neat facility.
Yeah, just a point of reference, I live in Cincinnati and I've been to that museum. That glass enclosed area that he pointed out is the center of the building, but the side walls of that building actually have 6 individual bays, which is where they built the transmitters with high voltage feeds into all of them. Most of them have been dismantled, but is there still one back in the back, Nathan? Did you see that one?
Yeah, there's still a transmitter in the back there.
It's like what, 50,000, 500,000, something like that.
Yeah, I'd have to double check, but it's powerful.
It's the only one left. They've dismantled all the others and turned the bays into part of the museum. Did you get to see the equipment behind glass, all the Drake stuff that's there?
Yeah, that's in a side room over there. It's beautiful.
It is beautiful. I don't think it was ever used. I think it's the stuff from the
coffee. Sure. Yeah. Yeah. So yeah, the Drake stuff is absolutely beautiful. So I'm in the room right now where they're doing the kit building. So they have, soldering equipment out for all of the campers. And we made, oh, you got this. So introduce yourself.
Hello, my name's Dylan, KN6IVW.
What are you doing, Dylan?
I just finished making one of these 3D printed straight key kits.
Cool.
That's really cool. So this is, you're talking to people from the TAPR organization. So a TAPR's, it's an amateur radio electrical engineering organization, and they're into designing software-defined radios and things like that.
Sweet.
So if you like building things and doing digital design and stuff like that, you might want to consider joining their group at some point. Right?
I mean,
Right.
You remember the question I asked about yesterday with the GPS and GNSS.
Yes, that's right. So he had a really interesting question last night. He said, well, if we can tell all of this information from the GPS and GNSS systems about the ionosphere, can we create a feedback to into our HF radios to improve our HF radio reception based on the information we get from the GNSS systems? And I said, I think that's beyond what we can do right now. But I said, that's very similar. You know, we're already doing that sort of thing with like the WAS, wide area augmentation systems for GPS to improve GPS systems. But maybe in the future, maybe we'll have enough information to be able to create a feedback loop for HF systems in a similar manner. I don't know.
Tell them about the system that we worked on, about at least 10 years ago. It was an automatic transponder system, and what it would do, they had intelligent radios on each end. What they would do is they had specifically assigned frequencies, and the radios would go through a list of frequencies and evaluate the path on each frequency, and it would pick the frequency that had the best communications path. And it was for military stuff.
That's so the ALE, right?
Yes.
Automatic link establishment?
Yes. And we worked on that with, believe it or not, Kachina 505 radios.
Wow.
If you remember those are ancient things. It's amazing that you could even do something like that with such old technology. Yeah. But so I have a question for you. Do you know code?
No, I do not.
So you're planning to learn code?
Sorry?
You're planning to learn because you've got a key now.
Are you planning on learning?
Oh, Morse code. I thought you were talking about computer coding. I'm like,
no, Morse code. Sorry.
Yeah, I do want to learn Morse code.
All right. Good. It's fun.
I bet.
And you're going to find out that in the ham radio world, when the contests come up, there are a whole lot of people that know the code that get on. So there's lots of activity. So it makes it a lot more fun. So yeah, congratulations on your key.
Yeah. I'm pretty excited to learn Morse code and all of that. Ever since I got into ham radio and learned what Morse code was, I'm like, how cool is that, being able to send across a message? Not only that you can sort of send secret code, but also that you can get through to very hard to reach areas with low propagation and all of that. So
it's like a secret language. It's like a different language, but it's English. So yeah.
So,
well, good. Hope you're having fun.
Oh, I am. I'm having plenty of fun.
Do you have your antenna that you made?
It's over in the other
over there, yeah. Okay.
So
yeah. Well, thanks.
Yeah, you're welcome. Yep. Thank you.
Are you you're a high school student still?
I am graduated from high school.
Oh, you're going to college?
I'm actually going to go to a trade school for mechanics.
What kind of trade?
Automotive mechanics.
Jay works is retired from the automotive industry.
Yeah,
I'm for that, don't you?
Retired automotive engineer, and coming up here in Detroit is a cybersecurity conference for automotive. So if you're interested at all in cybersecurity, automotive is leading the way in securing vehicles. So consider amateur radio as an entry point, as it was for me. Amateur radio was my entry point into the world of engineering, which led to my career in engineering. So consider amateur radio as an entry point into the world of technology in general. And there's so much opportunity for you and your other students there. It's really amazing what you can do. And also, when you're a ham, you have friends all over the world.
Hey, Jay, I bet you every single person on here is got their start in engineering in ham radio. That's like
interesting.
I mean, anybody who's not an engineer, yeah, right. Anybody who's in engineering that didn't get their start in ham radio. I mean, of course, this is kind of a narrow microcosm that you're talking to here, because we're all radio guys. So,
yeah. But that's not to say that you can do other things other than engineering.
Yep.
I know one of my best friends, one of the most active people at the W0EEE Club was a geology major. And another frequent, ironically, not many people go to Rolla, to Missouri S&T for psychology, but there was a psychology major. And you know, I mean, Bob Heil builds microphones, and you know, you have
Dave Larson's a forester.
Dave Larson, yeah.
I'm a forestry professor that worked with image processing.
Wow.
He didn't Sheldon say geology is not a real science?
Yeah, it's just rocks, Mary.
Yeah, my father was a geologist too.
Sorry,
geology is a theological field. Rocks have souls, don't you know?
Yes.
Yeah.
I'm a physicist, of course, but I design electronics.
Electronics is in everything. So no matter what field you decide to go into, you're going to have electronics in it, probably if it's a technical field. So in cars, I especially expect tons of electronics there.
Oh, yeah.
A modern automobile, a high-end car, can have easily 50 CPUs in it.
Hey, my low-end VW Jetta has more electronics in it than I have in my ham shack.
Yeah.
And I'm pretty sure your ham shack is probably chock full of electronics.
Yeah, it's pretty full.
It might have a few tube radios too.
Here, I'll show you my my real background here. They can.
Yeah. Ham cannot have too many radios or stuff in his shack. Having too much is a physical impossibility.
I strategically placed the Craftsman toolbox here to block the view of the electronics bench behind it.
Oh.
So anyway, yeah, if you're going into automotive, there's a real shortage of people who know what they're doing to work on not only passenger cars like trucks, but also diesel engines and heavy machinery, over-the-road vehicles, off-road construction equipment. There's a crying need for those kind of people. And one thing you will find is not only how to field strip an engine and do a timing belt or change out the bearings in record time, but you're going to need to understand all of the electronic systems that are on a vehicle. You're going to need to have a real good understanding and continuing education, because things are always changing. So you're going to have to get used to things like, well, it doesn't work. Yeah. Is there corroded contact on an electrical connector? It's nothing mechanically wrong, but we've got to be able to take apart a connector and diagnose that, okay, it's just corroded contacts, or there's some electrical problem there, and to diagnose down to the module level when it says it's not just an external contact, but there really is a fried module here. And then all the diagnostics.
If you're interested in working on cars, I recommend a show called Roadkill.
Just don't eat at the Roadkill cafeteria in the plant.
Have a real-time example of why we need people like you in the automotive field. I had one of those Volkswagen Jettas that they recalled, the diesels, the cheater diesels. And Volkswagen, I was going to sell it back to VW, right? So my wife got in an accident in the car right before it was due to be purchased back by Volkswagen. And VW says, I called them up and I told them the story, and they said, well, we don't care what condition it's in. As long as you can drive it in under its own power, we will still buy it.
Wow.
So my body guy, sheet metal, screwed stuff together and, you know, just Scotch tape and Band-Aids and put the thing back together. But the transmission had been hit in the right front. So the transmission was tweaked and it wouldn't come out of second gear. And so we got all the body work done, and we figured second gear, I can cheat that because the clutch still works. I can still drive it. So we get it all done, and then it wouldn't start.
Oh, shit.
And so I'm going like, oh my God, what? Because it has to run under its own power. I had 4 mechanics look at it. Not one of them could figure out. It would start and run about 1 second and then cut out, like the burglar alarm immobilizer thing was engaging, but it wasn't that, because there was an icon on the dashboard. It wasn't lit. So I had 4 guys who could not figure it out. Finally, the dealer said, well, you need to change the intake manifold. And I'm going like, no, that's not what the problem is. So I had it towed back to my house, and I got my volt ohm meter out. And I got the manual out, and I'm reading, okay, now what sensors do you need? And I mean, there's like 22 sensors on this engine. And there's 2 of them that are essential for the car to run. Either the crankshaft sensor or the camshaft sensor. You got to have it. If you have both, you're okay. If you have neither, it won't run. So I put my scope on the sensors, and neither one had any output.
Oh, wow.
So I'm going like, what had happened was the car had been hit and tweaked, and the wiring harness had been jerked. And so I measured on the harness, the sensors have 12 volts in, ground, and the sensor output. That's it. They're 3-wire sensors. They're really Hall effect, really easy sensors. And I found out that the plus 12 volts was gone on both of them. So in true ham radio fashion, I hot wired a wire from the battery over to the sensor terminal, and it runs.
Wow.
And I drove the sucker in, and I got my money from Volkswagen.
Holy crap.
And they didn't notice the little red wire that ran around the front of the firewall and down into the. And they told me if it runs, they'll buy it. So
I mean,
you were clear.
Are you?
That's what they said.
Are you a automotive mechanic, or are you just an electrical engineer?
No, I have a double E in computers and digital. But
So
I work on cars. I work on cars all the time anyway, but not the new ones with all this high tech stuff. So I'm just guessing, right? I don't know what's going on.
You're not even a trained mechanic, and the next thing you're the one who figures it out after taking.
I figured it out, and I'm going like, yeah. And you guys at the dealer would have told me to change the $800 manifold, and it would have done nothing.
Yeah.
Because you know what
well,
happens?
If you get to be a good diagnostician, that's what happens.
They plug it into the computer and it tells them what to do, and they don't have any idea whether that's right.
No.
It says manifold's bad.
I've had a number of problems in my Volkswagen that I've had to fix that the dealer couldn't deal with.
Yeah. But I mean, something so simple as this, it's like, the first 2, if it doesn't run, the first 2 things you check would be those sensors, right?
Sir, how are you? Yeah. Yeah, that's what my dad had, was one of those Volkswagen diesels that they recalled also, and my parents didn't want to deal with all the emissions that they were going to put on it, so they just sold it.
Yeah, so they sell it back to Volkswagen?
Yeah.
Yeah, same as mine. But like I said, it got in an accident like a week before we were going to turn it in. So I'm thinking, oh no, they're not going to buy it. But they said no, that as long as it runs.
Well,
so
anyway,
we need good mechanics.
Long story short, that gives you some idea. So it's not just mechanical. You need to know the electrical, and you never know when you get something to fix where that problem is going to be.
Yeah.
Good roadkill mechanics.
And especially today, being able to break into the computers and being able to fix them, it's a little more work, but if you can't get parts for the car or whatever, because of all of this supply chain issues.
Yeah, you're not going to fix the actual module itself. The actual electronic control unit is a replace.
Hey Jay, don't underestimate him.
Yeah, don't underestimate.
Yeah,
sometimes you can replace it if it's an interface chip.
Yeah, I mean, if you want to open a business that reconditions and refurbishes them, but that's a dedicated business of doing that. If you're the guy that just, hey, I got to get this thing fixed and back out into service, you don't go past the module. You troubleshoot down to the module and then say, okay, it's definitely in the module. It's not a wiring. It's not a connector problem.
Hey, don't tell us what to do. Go in and fix it if we want to.
No user serviceable parts inside is a challenge to me.
What I'm talking about is him in his business, in a day-to-day running of the business. That's what you do. Now, what you do on your own private time, you know, if you want to, you know, fool around with your own private time, repair your own, go for it. Open it up, do whatever you want to do. But in terms of, hey, you got to get this machine, this truck fixed and back on the road, because when it's in the shop, it's not earning money.
You know, you may find out a lot of times that the fix is so simple. A friend of mine had a piece of stereo equipment. There's a $300 box. It was some kind of equalizer. I didn't even know what the thing did. He said it was broken. And the guy at the shop said, well, we can order a new board for it, but it would cost more than a new unit. So you should just throw it away and go buy a new unit. So he gave it to me. I took it home and I opened it up, and it's a huge big board full of op amps. And I have no schematic. I don't even know what the thing does, right? But I put my scope on it and I find out that the minus 15 volt power supply is dead, an 89-cent regulator, and the thing's fixed. And it's a $300 piece of equipment. And it's like, but like Jay says, nobody fixes the boards. They just throw it out and put a new board in.
Yeah, that happens all the time.
But again, there are companies.
If you have a bad piece of electronics, check the electrolytic caps first.
Yeah, they refurbish them for a living. That's their sole business. So you take a defective module to them, they just give you another one so you can be on your way, get the vehicle back on the road, and they take the one you turned in, they refurbish it, and then resell it.
They replace the 10-cent regulator.
But you also have to worry about.
Hey, you underestimate us. A lot of us hack our equipment.
I'm talking about when somebody's doing this for a living.
Yeah, who said we're doing it for a living?
Well, he is. That's what he's going to be doing. And what you also have to be concerned about now is cybersecurity, because just because you replace a module, it may be the same part number, but cybersecurity will prevent it from being integrated onto the vehicle, because the vehicle will recognize it as a foreign module. So you may still wind up having to go to the dealer to have them use the proper code, which they can only get from the manufacturer, to marry the vehicle and the module to the vehicle, to let the other modules know that it's a legitimate module and not to go into anti-theft mode.
The radio only works with that module, right? So you can't just
that
change
specific
the radio.
module.
Right. Yeah, we know.
And the vehicle yourself.
Bro,
John Deere does that.
I'm holding your sunglasses. Okay.
So yeah, just be aware that those systems are out there. That
that's
just
what
because
right
you
to
put the same
repair
part
is
number
working
in
against.
doesn't mean it's going to work. And sometimes it'll just mean that module just won't turn on. Other times it'll just mean the car goes into anti-theft mode and just won't run.
Yeah. I've looked for an ECM for my 64 Volkswagen and I can't find one.
That's not my problem.
So I would like to turn off the recording. All of this stuff has been recorded, so I'm going to end the recording now.
Do we get royalties for fun stories?
I guess so.
So usually we post these to YouTube afterward. So if you don't want your part posted to YouTube, I can cut it out. We don't care.